All right, question 7, we have an elevator. We have 2 blocks inside the elevator. Each has a mass of 3.8, and they're hung from the ceiling like shown. The elevator has an upward acceleration of 1.4 meters per second squared, and the strings have a negligible mass. We don't need to worry about the mass of the strings, so just the blocks. Find the tensions T1 and T2. Okay, so there's a couple of ways of looking at this problem. That's why I did put it in there. If you are looking from outside the elevator, you will see the blocks moving up. You will have a net acceleration in the positive y direction. If you are inside the elevator looking at the blocks, you will see an acceleration downward because you are in the elevator feeling the acceleration according to Newton's third law, the equal and opposite reaction. So there's 2 different ways of looking at it. One brings you a positive number, and the other one you have to put in as a negative number in equilibrium. Okay, so either way it works out, as long as we can picture this correctly. So what I want to do is do a free body diagram for one. I'm going to start with T1. Okay, so for T1, I have this mass and this mass, and the whole thing is going to point downward with the force of gravity, which is equal to mg. And the mg that T1 here is feeling is both of these masses. Okay, so it's the total mass times the gravity. So what this is going to be 7.6 times 9.8. Okay, because it's both masses. T1 is holding both masses up. So if we do a sum of the forces in the y direction, and I'm looking outside of the elevator. If I'm outside the elevator, I do see that they are accelerating upward. So I would have an MA here. Okay, some acceleration, they are accelerating up. And I would set that equal to T1 minus the 7.6 times the 9.8 minus FG. Okay. The mass over here, I would use the same mass, and I know what the acceleration is on this one. It told me it was accelerating at 1.4. So what I want to do is I'm going to plug in M, I'm going to plug in A, and I'm going to add that to the other side. Okay, so what I'm going to have is T1 is equal to 7.6. So this is the MA. Okay, T1 is equal to 7.6 times the 1.4 plus, now I've added this to the other side, 7.6 times the 9.8. Okay, this is just a number. If I put that out, I get 85.12. Okay, so that's how we get T1. For T2, you see it's going to be the exact same equation. Okay, you see it's going to be the exact same equation, but T1 won't be there. T2 only depends on the one mass. The one mass is hanging on it. If there was no mass, you'd have no tension. So T2 is dependent on this one single mass. Since the masses are the same, you've just eliminated half of the force. You can do it back out if you want. Same acceleration of the elevator, except for now the masses are exactly half of what they were before. And if you calculate that out, you'll get exactly 42.56, or half of this. Okay, so this problem is rather simple on that part if you can make that understanding. Okay, that T2 is equal to 1/2 T1. All right, so that takes care of part A for you. Part B, if the strings can withstand a maximum tension of 92 newtons, what is the maximum acceleration of the elevator before the string breaks? Okay, to figure that out, we're going to use the same equation. But in this case, I want the maximum tension to be 92. So the one that had the most tension was T1, right? So that's the string I want to be concerned with. If T2 was 92, then I know that T1 would be double it, or 184, which is no good. So if the strings can withstand a maximum tension of 92, we only need to be worried about T1 becoming 92 newtons. So what I want to do is the same equation, okay, that the sum of the forces in the y would be equal to the 7.6 mass times some max acceleration. So in here I'm not plugging in 1.4 because I want to figure out what the maximum acceleration would be. And I want to have that equal to T1, which is going to be the maximum tension. So that would be a 92. 92 minus 7.6 times 9.8, because the force of gravity remains the same. No matter what tension you put on the blocks have the same force of gravity on them. Okay, so now we're just solving for a max. So this is just a number on this side. I'm going to take it and I'm going to divide it by 7.6. Okay, so let's do that quick. I'm going to have 92 minus 7.6 times 9.8. That will give me 17.52. And then let me divide that. So 17.52. We're going to divide that by 7.6. And that'll give us our A max, which should come to, 2.305. So 2.3 meters per second squared. That's how we get our answer for part B.